Hello and welcome to Mike Dolan Games and another tutorial that's related to our making a space sim in Unity tutorial series. This tutorial today is going to be probably broken into a couple different videos. We're going to cover creating an AI for our spaceships. The system itself could be standalone in terms of like you don't have to actually use it for a space game, but um, you could apply it to other AI as well. But we will be doing this through a lens of a space game. If that's what you want to do, then this would be great for it. And then if you want to try to apply what you learned to another style, that would also work. So we're going to cover behavior trees, and I was thinking about making some AI to get our enemy ships flying around and chasing the player and dodging asteroids. And I thought about, oh, I could just make like a really simple finite state machine. And the more I thought about it, and the more I thought about this tutorial series, I'm trying not to just do things kind of in the quick and dirty way, and I would rather kind of show you the things that I like to use in my games and what I'm interested in. So while I'd love to just make like a big um, if-then statements or switch case or something like that of a couple different behaviors and just kind of get something on screen for you, I thought it would be more useful to talk about setting up a behavior tree system. So let me show you what I'm talking about. Okay, so for a long time I've been actually using an asset from the asset store called the behavior designer, and it's a great example of a behavior tree system, and it uses some visual scripting, so it's a lot easier to kind of set up your AI and debug it. There's still a little bit of a learning curve and just understanding how to create this kind of flow chart for your AI, and then also if you really want to make things work for your game, you're probably going to have to program some of your own tasks and behaviors. But this is kind of the basic idea of what it looks like. So you have things like sequences and selectors, which we'll get to in our system that we roll our own. And so a sequence just kind of goes through a list of activities. And as long as they return true, they'll keep going. And then a selector will go through a list of activities, but it will kind of check one left to right, and if it fails, it will go to the next one. Okay, so it's kind of like choosing between them, but it will always choose the first one first if it succeeds, and then it won't go to the next one. With the sequence, as soon as one of the things in the sequence fails, it shoots back up to reset the tree to evaluate. You can have kind of a list of things to do, and maybe there's a check that just says, okay, we're done. And that's it. You can use a sequence to do that as well. So we're probably going to try to get a sequence done today, and we'll also have selectors and different types of tasks and things like that. So anyway, I'll put an affiliate link in my YouTube description for you for the behavior designer if you want to check it out. It's not the cheapest asset, but it's actually one of the best assets on the store. It's definitely not kind of a throwaway asset. It's very well thought out, well documented, and it makes your life a lot easier for designing AI, if that's what you really want to get into. But it is a powerful tool. So anyway, but that's not what we're going to do tonight. You don't have to get this. We're going to make our own behavior designer style behavior tree. So it won't be pretty like this. We're going to use lists to do ours in code, but maybe in the future we can add some sort of UI to make it as cool as this one. So I think I kind of gave you the basic idea of what a behavior tree is, but so the main parts is it's like a flow chart. It's a little bit like a finite state machine, but it basically allows you to have like smaller tasks that break down, and then you can add them to sequences to create kind of complex AI behavior and thinking. So think of it like a flowchart kind of thing. The main parts of it, there's sequences, there's selectors, there's tasks, and there's also like conditional things where it's just like checking whether a variable is true or false or something like that, and you might flow from there. So the AI that I have set up for this demo actually has kind of all those things in it. We're looking for a target or looking for a waypoint. We're checking to see if we've reached the waypoint. We have tasks to turn and move towards a target. We also have built into our turning, we have collision detection. And these guys are all chasing me. But and then we have a random die roll to decide whether to just keep going to different waypoints or not waypoints, but random wander points, or chase the player. So, okay, so let's get started. So just open up your tutorial project that you've hopefully been following along with. This could be a standalone system, but if you've been following along, I'm going to kind of integrate it into our tutorial scene. So we left off with kind of damage systems and lasers and things like that. So it should look something like this. If we go to our ship, we have our ship controller and a few other things. So the first thing we're actually going to do is we're going to open up our, the first thing we're going to do, let's just go into scripts and create a folder and call it behavior tree. Let's just get it out of the way. Okay, and I want this folder so that we can kind of organize all of our behavior tree scripts. We're going to have a bunch of classes and things like that, and a bunch of individual behaviors and things that we can kind of separate from the rest of our game code. All right, so once we have that, let's open up our ship controller. I've got a few changes that we need to make in here. Okay, so the first thing we need to do in our ship controller, now this is the main controller that takes the input from either the player or the AI using this controller input interface, and sets up all the events to control how the ship is controlled, right? So one of the problems with the way that I've set this up is it's very hard to control the AI ships with yaw and pitch. So I created a new method called turn to target, and it's already in here. Sorry, I'm not going to be typing this along with you, but if you want to type this in here, just private void turn to target. It takes three variables, basically a vector 3, so an x, y, and a z floats, and then it's going to make a new vector using those for the desired heading. I can't remember exactly why I made these individual. You might be able to pass in a vector, I can't remember, but we can look at that when we do the AI part. So we're going to create a desired heading vector 3, and then we're going to create a rotation goal using quaternion look rotation to the desired heading, and that's going to get kind of where we want to turn our AI towards. And then we're going to create this step, which is the yaw speed times time dot delta time. That's going to just basically cut up how fast we want the ship to turn based on time rather than the frame rate. And so basically yaw speed here, while it's not the same as when your player is moving, yaw speed here is basically the degrees per second that you're turning. So keep that in mind when you set this. If you wanted to turn 30 degrees per second, you put in 30. And then transform rotation equals quaternion rotate towards the current transform rotation and then the goal. And then do the step, which is basically that how fast we're turning. So that will make a nice smooth turn. All right, so that's just our turn to target function. It's very important for our AI. And then the last thing we need to do is our AI is going to start like setting itself up in the start functions of their own component, so the AI component. But we need access to these events. So one thing we can do is we can use Unity's monobehavior awake function, which actually runs before the start function, before all the start functions. So what I want to do is move this pilot check into the awake. Okay, and this is just going to set all of our player input events in the awake function rather than in the start. And then the other thing I added here at the end was just a an debug error so that if there's no pilot, you can kind of check for that here. Okay, so those are the two things we need to do with the ship controller. Move the pilot check in the event setting to the awake, and put in the turn to target. If you don't do the awake thing, sometimes your events won't get set up in the AI, and the AI will just sit there because they basically got set up before these events were called, basically just the script order. So that's why. Okay, so we have our ship controller, and we are going to now go back into Unity real quick, and I want my behavior tree folder to show up. So I'm going to right click on my behavior tree, and I'm going to create a C# script. So we're going to start with our first piece of our behavior tree. So the behavior tree is set up on well, now we have a new button behavior. So call this new behavior, I'm going to call it behavior tree node. So BT node, and I got to fix mine, so I'm just going to call it BT node. So all the tasks and behaviors of the behavior tree are going to be based on this this BT node class. All right, so we're gonna implement this class and override a bunch of things in it. So we're gonna give this a abstract class, and we will make it system serializable. Okay, and we don't need these mono behaviors. We're actually not using mono behavior here, you'll notice. Oops. Okay. All right, so within this, we are going to have a couple things. So basically, we have the BT node constructor, which is super simple. It's just empty, essentially. Okay, and then the second piece that we need is a method for this BT node, and it's called evaluate. Okay, so every time we run our behavior tree, we're going to evaluate the different nodes, the different tasks, the different sequences. We're going to run through them and evaluate them. And evaluating is where a lot of the logic will be. So we're going to make this an abstract too, because we're going to change the way this gets implemented. And we're going to return a state, and the state basically is going to be success, failure, or running. So I'm just going to put it here for now. Oh, we can, so instead of cluttering this up, we'll add a script, and we'll call it BT node states. Okay, and if you do this from the Unity editor, everything will be set up for you. But okay, so in the BT node states, we don't actually need, we don't need any of this. Okay. Yeah, we just need we're just going to make an enum. So public enum BT node states. Okay, and then success, failure, and running. And these states are basically like the kind of the magic of the whole behavior tree. This is every time you run a node, these are what's going to return. So, okay, so back to this. Now that we have our BT node states, this evaluate function is going to return that. Okay, so I don't need to actually do that. Okay, so now we have our constructor here. We have our BT node states evaluate. Okay, so that's our method. And when you build different tasks and nodes and things like that, you can add more methods, but these are the ones we need for this. For every node that we have, we need to have an evaluate statement. Okay, so the other thing we might want to know about, now that we have our BT node state, is what's the state of our node. So what is our node state? and we can use a getter for this. That way we can't change our node states here. But we can use this to find them. Current node state. And we will need to add our own protected BT node states, current node state. Okay, so this is one thing we'll store in all of our nodes is a node state, and then we'll have a getter to get it. Okay, and then the other thing we need is the evaluate. So I know this isn't the most exciting code, but it's going to be the basis for how we set up everything. So okay, so we're going to now make another script in our behavior tree file. So I'll do it from Unity this time. So create a C# script, and the first thing I think I want are well, we'll do a sequence. Okay, so call this script sequence, and you might want to have BT sequence or something like that in front of it, but I'm not sure we're going to have another sequence class in our whole game. But okay, so sequence is important because it allows us to have a bunch of AI behaviors. So it's a little bit tricky, but we'll get through it. Okay, so we are going to not use mono behavior for this. We're going to do a BT node. So we're going to pull from BT node. Okay, now we're getting angry because we don't have the evaluate function here. So we just have these mono behavior functions, which we don't need. So if you're using Visual Studio, you can just highlight over this and yeah, you can just click it and implement it. Okay, so now we have our evaluate class, and this is how it should look. Public override BT states evaluate, because we're going to return a state. Okay, the other thing we need though is a constructor. So, and when we make a sequence, we're not just going to throw a sequence into our behavior tree. We have to build it, because a sequence is actually made up of a bunch of nodes. Okay, so this is going to be a list of nodes. So when we make our sequence, we're going to send it a list of nodes, and all those nodes will be evaluated. And we're going to call it, oh, I need to make my variable, sorry. So we're going to private list, and you guessed it, BT node, my nodes. Okay, so we're going to set up a node, a list of nodes, and we're going to get it when we do our constructor. So my nodes equals nodes. These are the nodes that you're passing in, okay? And you're setting it to this. All right, so that's how you construct your sequence. And then we're going to have our evaluate function, and basically the evaluate method is kind of where everything happens. Okay, so this evaluate method, I know I said, oh, it would be so easy to create a finite state machine using a switch. Well, guess what we're doing? We're going to create a switch. So, okay, the first thing we're going to do is we need to make sure as we're going whether things are running or not. So we're going to have a quick local bool child running. Most of our AI for this project so far is just going to be very simple, and probably won't be having like extra frames of running, but we'll have this in here as a check. So okay, so now we're going to loop through every node in our sequence. Okay, so we're going to do a for each for every BT node. We'll just call it node in my nodes. We're going to do something, and what are we going to do? We're going to use a switch. And switch is like a big if statement essentially. So we're going to evaluate node.evaluate. Okay, so this is pretty tricky. What is this doing, Mike? Okay, so what we're going to do is, in our switch case, we're grabbing the node out of the list, and then in our switch, we are going to run our evaluate function on that node in the list. So we're going to run through the list in order, and we're going to evaluate each one, okay? And so whatever the evaluate returns is going to be what our switch case looks at. So, and what does the evaluate always return? It returns a node state, okay? So we're going to have a bunch of cases. We're going to have a case for bt node states dot failure, and I'll just put them all in here. Case bt node states dot success, and case for bt node states dot running. Okay. All right, so we're going to have all these cases, and so we're going to evaluate. And if it's a failure, it's going to do something. If it's success, it's going to do something. If it's running, it's going to do something. Okay, and then let's see here. You can also have a default. And I don't know if that's really required, but we'll have that. And I'm just going to have it return current node state. Okay, so we're going to run through our switch case. And we're going to do something. So, okay, so if a sequence fails, we want to stop the sequence. So if we get back failure, then our current node state, this is now we're setting the sequence node state to failure. Okay, so if one of our states fails, we're going to fail too. Okay. And why is it angry at me? Should be fine. Okay, and then we're going to return current node state because evaluate always has to return a node state. Okay. Now in success, if we succeed, we're just going to move on. Okay, that's great. Our node succeeded. Let's go to the next one in our sequence because we want all of our sequence to go through. If we're running, we're just going to set child running to true, and we're going to continue because we don't know if we failed or not. So we're just going to keep going. And then if we're default, we're just going to set it to success. All right, and keep going. Okay. Finally, now these should all evaluate. I guess if you go to continue, you're going to get out of the switch case, right? So underneath the for each, we just need to do another return and the current node state, okay? And the other thing is down here. If we go through our so since we're continuing here, we have our success, and if our child is running, we'll just do a quick check. So if child is running, we're going to set our to running, or we will do success. Okay, so what does this mean? Okay, if we get down to the bottom here, we are going to check to see if we continued because our child is running, or if we continued because we had success. If the child is running, right, if current node state equals child. This doesn't look right to me. Why isn't this working? Oh, wait, okay, so alright, yes, okay, so yeah, this is fine the way it is. For a second I was like, wait, the if statement's here. No, the if statement's this. Okay, so we're setting this to one of these two things, and this is just evaluating whether it's true or false. It's kind of a tricky ternary, just because it looks like you're trying to set this to child running, but that was just, my brain melted for a second. Okay, so we're going to set the current node state to either running or success, based on whether child is running or not. So, okay. And we do that because in here, we don't actually set the state. All right, so that's the sequence. Okay, so this is going to take a pile of nodes, but we don't have any nodes. All we have is a sequence so far. Okay, so yeah, let's make something that we can stick in here. So let's think about this. So our ships, in my demo, they fly around to random points, or they fly to the player. So it's a little easier since I don't want this video to go super long. So I think what I'm going to do is set up the random location first, and in the next video we'll do the kind of go after the player, and then make the behavior a little bit more complex. So to create a sequence that finds the location and then evaluates if it's close, and then flies to a new location, we need a couple different things. So we need to be able to find somewhere to go. We need to move. We need to turn and move to that target, and then we need to check to see if we've arrived, and then do it all over again. So I think that is what we will do. I'm trying to think here. We might still need a selector now that I think about it. Okay, so if you remember, a selector basically just evaluates something and then decides to whether to do it or not. So let's make another C# class, and we'll call it a selector. All right, and we're going to make it a BT node. We don't need any of these things. Remember, if you just hover over, and you can let Visual Studio write out your evaluate anyway. Okay, so a selector is very similar to a sequence, okay? So we're going to make a protected list again. Nope, not an array list, just a regular list. Not an array list, just a regular list. I don't know why it's being angry at me. Do I need a different... Yeah, I need generic, I think. Okay, so if you're doing this... Okay. Alright, so make sure you have a generic here. Okay. We're going to have a list of nodes. Call them my nodes again. Equals new list BT node. Okay, so now you have your list, and we're going to have another constructor, just like in the other one. Selector list BT node nodes. Okay, so when we build our selector, we're going to pass in list of nodes, and we'll set it here. All right, so now same deal as our sequence. So what I'd advise you to do, rather than keep typing the same things, you can just grab this for each loop and copy it. Okay, we're going to change it, but it'll save you some typing. Okay, so now we're going to loop through our nodes just like we did before, and we're going to evaluate them same way we did before. So every node, we're going to hit it, we're going to evaluate. Okay, so if we get a failure in a selector, we're going to continue, because we want to keep going down the list of things. So if one fails, then we say, oh, okay, well, we're not doing that one. Let's go to the next one, okay? If you have a failure, you're going to continue. If you have success, then we're basically done. So we're going to evaluate whatever is in that successful node. So you could have a sequence, right, where it checks something and then it does a bunch of things. So it could be like in like a first-person shooter, you might have a check for like need health. So the enemy will check whether they have enough health, and if they don't, you could say success, and then the next step would be to search for a health pack or something. So you'd have a sequence that gets evaluated in this selector. Okay, so if we have success, we are going to set the current state to success, and then we're going to return current node state. Okay, and then if we're running, we don't even care, so we're just going to do default. And the default is basically running, so we're just going to continue here. Okay. All right. Okay, yeah, and then we still need to return something at the bottom, because if we have a default state, then we'll have a problem. So current node state. And if we get down to the bottom, we're just going to fail. Okay, so yeah, I think that should work fine. So basically, this is just going to evaluate whether it's success or failure. Maybe in the future we might need a running one. I don't know if that matters or not, but okay. So at least for my purposes so far, it hasn't been a problem. Okay, so failure and success. And remember, if you fail, we're going to continue. Check the next node. If we succeed, we're going to stop and just return success. Okay, that is our sequence. Now we can get into finding a random point. Okay, so this is going to be our first task. So we have our selector and our sequence, but we're going to create a task now. And so it's going to come right out of another BT node. We're going to call this find wander point task. And you can call it whatever you want, random waypoint. I think of it as a wander point at this point, because this one's just going to be very random, so it's not like an actual waypoint. All right, so in here we are going to need a range. Okay, so this is going to find like a range. Basically, this is like the radius from the center point of the map, and it's just going to pick a random point in the whole range. So okay, so we need that. We need our public find wander point, and then we're going to put in our range, and I'm just going to put an underscore here so that we don't have the same variable name here, like that. Okay, so now we're going to do this, and we have our final piece that we need is our public override much easier to let Visual Studio do it. Okay, so once again, this is a node, so we need to evaluate, but we're not going to do anything fancy here, so we're just going to find a new target. So how do you do that? You're just going to set the target using a sphere, so a random sphere. So here, we're going to need to do something like This is going to be a vector 3. New target, we'll call it goals random dot inside unit sphere, and you could do you could just do unit sphere, and then it would be on the outside of the sphere itself. But this will pick any spot inside this sphere, and then range. So you could do like 1,000 range or something. All right. Yeah. Okay. There's a big problem with this. Oh, and the last thing we're gonna do is you need to return BT node states.success. Okay, so we're just going to do this. There's no reason to fail here. Okay, problem with this is we have a new target. How do you get this information to our AI? Okay, we have our ship controller, and we actually don't even have an AI controller yet for our ship. So that's another thing we need to create. Make sure you're naming these things as you go. So a couple of things we need to do. We need a way to pass in which AI ship is being controlled by this particular behavior. So we're going to need to pass that in. And then we could use that object to set the target so that we can share that variable, that information, with our AI behavior tree. So we don't have that set up yet. So that's what we have to do. Okay, so how do we do that? Okay, so the first thing we're going to do is we're going to create a iController input, basically, but instead of the instead of it being a player controller, we're going to do one for a AI controller. Okay, so here, we'll do this in Unity again. So in your scripts, create C# script, and we'll just call this AI controller. All right, open it up. All right, so our AI controller is going to take controller input. All right, so now we have to implement this interface just like we did with our player. And you can actually just do this. Okay, so if you have Visual Studio, you can just have it auto fill in for you. Okay, so now we have all these events. We're not going to use all these events in this AI controller because we don't need to. But we will be using our turn event that we created. Oh, and if you, I think I forgot to add this to the, to tell you to add it to the interface. So one thing to add to the interface is this turn event, so that when you have it in your ship controller here, turn to target, it's going to do that turn to target method that we talked about earlier. Okay, so we have our AI controller. We're implementing this input system, so we can use ship controller. Okay, the other thing that we are going to do is we are going to need another interface to kind of pass information on, but just for AIs. So I don't really want to bog down the controller input with lots of AI script stuff, because there's, the player won't need it, and then there's no reason to have it all in a iController input. So we're going to create another interface. So let's see here. Yeah, that's what we're going to do. Okay, so let's go back to your scripts, and I guess you could put it in your behavior tree. So another C# script. We're going to call this iBehavior AI. And so this is our behavior AI interface. Okay, so now we have this, and we are going to We don't need it to be a mono behavior. We need it to be an interface. All right, and then we're not going to instantiate this stuff. Okay, so in here, a couple things that we'll need in order to go to the target are vector 3. We'll call it set target position. Okay, so now we can pass a target position to our AI. And let's think about this. That's mainly what we need to do here, I think. So we'll build out this interface as we go. I think that's a good way to do it. Okay, so let's say that's all we need for this. And I might be wrong. Okay, so take this interface, go back to your AI controller, comma here, and add it. Now you're going to get a red. It's going to say, you need to implement the one thing that we have. Okay, so I'm not going to have it here, though. I'm going to put it down here. All right, so we have to implement the set target position, okay? And the set target position is basically just going to, let's see here, we need a variable, and we're going to just call it target position probably. I'm trying to think of, yeah, we'll just make it public vector 3 target position, and then we can just set this to 0 for now. You can probably just leave it undefined, but set it to vector 3 0, and then in here in your set target position we are going to here, I'm going to call this my target position. Okay, so then my target position equals target position. Now this is a way for our AI script now can pass this information in. And the last thing, I just wanted to set this up to return the target position that we got. Just in case we want to use it somewhere else. Okay, so we can pass it in. All right, so now we have a way to set our target position using this AI controller. Okay, so now we have our wander point, and in our constructor here, we're going to have to add something else. We're going to have to add the I behavior, AI, we'll call it my AI. So now we're going to pass this AI object in here, which has that function. So, and then here, instead of new target, we can do my AI. Oops. Oh, okay. We need to add my behavior, my AI, here, and then here we'll set it. You gotta remember to set everything up in your constructor. Okay, so my AI equals set target, and instead of equals now we have a method. So we're going to just set the target position to this. And now when we have our other AI scripts to go to that target, they'll be able to access this through the my AI interface. Okay, so now we're going to return it, and we're going to set it, and then we're going to return a success, and that is that. Okay, so again, I'm just trying to loosely couple this stuff as much as possible, so that we don't get bogged down in like what kind of ship it is or how that ship works. We're just going to have AI that will connect to the behavior system using the interface, and we won't have to worry about it. Okay, so, and we can use the same ship controllers and things like that everywhere. Okay, so now we have our wander point. So our AI is going to go through a sequence. It's going to find the wander point, and then it's going to go to the wander point. And once it gets to the wander point, it's going to say, we're at the wander point. And then it's going to find a wander point again. So we need a check to see if we're at our wander point, and we need the ability to move. So let's create a move script. All right. So we're going to make a new task, and we'll call it move to target task. And I just like using the task label for these so that I know what's a task, what's a conditional, what's a sequence, what's a selector. Doesn't really matter. You don't have to, I guess, but public class task. Let's see here. Yeah, and then okay. So let us set up our first kind of exciting thing. Okay, so now we're going to, and of course this is going to tell us we need to evaluate. All right, so just like all tasks, we need a constructor. We need to set up some of our variables. So first, our variables. We're going to need our AI again. Oops, because we're going to look at our target, right? The other thing we're going to need for this is a like our position, so the position of the AI, which this task is not going to know unless we pass it, and then the target position. So the target position is the target position that we set in our iBehavior AI. So we should be able to get that, and then lastly, we need to have a event as well. So since this is the move event, the for event is what we want. Okay, because just like in our player script, we I don't have it open, but where's our ship controller here? The forward event, right, passes the forward thrust. So once we know that we're going to go forward, we just do our forward thrust, add some force. Okay, so that's going to do, this is what that's going to do when we have it. Okay, so yeah, so I'm just going to add some variables here. So we need a vector 3 for the agent position, so that's our AI position, and then a vector 3 for our target position, and then we could have a range factor here. So yeah, we could have a range factor, and that could be like how far do you want to be before you kind of like slow down, I guess. All right, and then let's see, I think that's everything we need for our variables. Okay, so now we need our constructor. So the constructor public move to target, right? And we're going to take my behavior, my AI, take a range, and we'll take our input event. We're just going to pass our input event here. We could add it to our AI behavior, I guess, but that would kind of like muck up the different things here. So we'll just do it here, forward event, and we want to range to like this. Okay, so now we have this, our constructor. So we're just going to set my AI to equal AI, and we're going to set range to equal range, and we're going to set forward event to equal forward event. Okay, so we've constructed our stuff. Now we want to evaluate. Okay, so alright, so this is where we need to add more things to our behavior AI. Okay, so our behavior AI needs to give us an agent position and needs to give us the target position. Okay, so right now, we don't have these things. So you know what, I'm going to jump ahead. I think what I really want is the transform, because we could just get the position from that. Okay, so let's just do that. Okay, so we're going to get the agent transform, we're going to get our target position, because right now we're just using vector 3s for that. So in here, we need to do something that returns a transform. We'll call it get transform. Maybe we can't use that. We'll call it get agent transform. And then it takes nothing, right? It's just going to return a transform. I think that's fine. Okay, and then we need to do a vector 3 get target position. So now we are going to return the vector of the target position. Okay, so now once we do that, if you go back to your AI controller, you'll see that our behavior is mad again. So you can just implement them. So they'll show up down here. All right, so we need to get our transform. So we're just going to return transform. All right, and then this one, we're going to return the target. My target? What do we call it? My target position. There we go. Okay, we're going to return that, and that's how you do that. Okay, so back to move to target. Now we have two more things to add here. So agent transform. Actually, we don't really need that there. If we set it in the constructor, then by the time this behavior happens, the transform and the target position might be out of date if they're moving. So we'll put it in here. Okay, so agent, and I'm going to do a vector 3 agent position. See, now we're evaluating. So when we get into the evaluation, get agent transform dot position. Okay, so we're grabbing the agent transform, we're getting the position from it, and then vector 3 target position. Oh, we don't even need to. Well, this one we need to set. This one we don't. Okay, and we'll equal this to my dot get target position. Okay. Oops. So now we have the two variables we need. Okay, so one thing I like to do is kind of like moderate the amount of thrust that we're giving it. So just kind of like a player might ease up on the throttle or not. So we can do that with this. So the way to do that is to figure out what the distance is. So float distance equals vector 3 dot distance, and then you can do agent position, comma, target position. It's going to give us a distance between those two vectors, and then we can kind of moderate the thrust with this, and add the range in, or how close we want to be, and then let's it's always important to check these things. So if forward event does not equal null forward event, the rest. Okay. And you could add debug check here. That's kind of how I found out that you need to do these in the awake. So it can be important to have this check in there. The AI will break if the forward event's not there. So you need to make sure you're checking for it if you're going to try to do it. And then we're going to return node states success. Okay. All right, so we're going to succeed. Move on to the next thing. Okay, so now we have move to target. The one last thing we need to do. Man, okay. Sorry, this is so complex. We have a bunch of scripts to make this all work. So we need a turn to target script and a check to see if we've arrived. So let's do it, and then I think we'll try to implement this and then see if it works. Okay, and call it a day. Okay, so turn to target. Make a new script in your behavior tree. Call it turn to target task if you want. It's going to derive from the BT node. We don't need any of these things. We can have it create the evaluates. All right, so for this, we're going to need our AI again. Actually, if you go to your move to target, you can kind of just copy this. Oops. And paste it in here if you want, and you can just fix it. So okay, so we don't need range, I don't think, and we're going to make this the turn event. And so we're going to have a event input. Wait, do I need input? Do I need? Oh yeah, okay. Event input event vector 3 return event. Okay. This is capital. Okay. Oops. Okay. So we have our turn event, and we'll do turn event equals underscore turn event. Okay. And no range. All right. So we're passing in AI. We're passing in our event. It doesn't like this. Why? Oh, I set this to a float. Vector 3. Okay, the turn event takes that vector 3. So, okay, so now in evaluate, things that we're going to do, we're going to get our positions again. Okay, oh, I need to fix my name here. Okay, so we're going to get our positions. Okay, so we're going to get our positions, and then we're going to take a desired heading. Alright, so this is going to look a little like what we did in the actual turn to target method. We're just getting the target position minus the agent position. And that's going to give us a desired heading. Wait. Yeah, we need that. Okay. And then if. So I have a check in here. You can experiment with this. You may not really need this, but this is just checking if we're like pretty close to the desired heading, we don't really need the turn. So like maybe sometimes turning is good enough. Oops, what did I do? Yeah, that's fine. Okay, so basically this just checks the angle. If it's greater than 10 degrees, then we're going to turn, and if not, then we won't. So I don't know. It's kind of yeah. Why did I make this a vector 3? You might just want to do a vector 3 here. I don't really remember why I programmed it this way, but so we can pass this in here. We're just passing in the turn event that we passed through this constructor. Okay, and then we're going to return bt node states.success. Okay, so and then our evaluate should be fixed. All right, so what this is going to do, it's going to get our positions, it's going to figure out our desired headings. If we're okay, we'll turn. Okay, and then it's going to return success. I suppose we could turn a failure here if this doesn't work, but it doesn't really matter that much. Okay, so we're going to do that, and then okay, so one of the things to note here is that because this video is long and there's a lot of setup, I'm not going into collision detection here. So right now we're going to fire this up, and then the ship's going to promptly crash into an asteroid probably. So, but we will have to create that next time, or you can try to do it yourself as a challenge for the next time. I need to make one more script, I think, and that is to check arrival task. Okay. All right, and check arrival task. And it's another node. Okay, so this task is going to be super simple as well, and it's going to take a bunch of things. So let's see here. We need to give it the. All right, let's start with our constructor. Public check arrival task. And then I'm going to take the AI behavior interface again. We'll call it my AI. And in here, my AI equals, oh, my AI, okay. So we do need a okay, so you need a behavior interface of my AI. You're going to set it in the constructor, and then we're going to do our evaluate. And in here, we need to do the same thing we did here. So we're going to get our positions again, because now we're going to check our distance. So we can steal this distance here as well. Okay, so we're going to check, we're going to get our positions, we're going to check our distance between them, and then now you could set a variable for this. I'm just going to say if we're within 100 units of the thing, then we've hit our target, or we're close enough, and we're going to return success. Okay, and then else return failure. Okay, so now this is going to say if we've reached it, we're going to do something else, and if not, we're going to return failure. Okay, or in a sequence, move on to the next thing. Okay, so we're going to need this to work this way. Okay, so this is just checking the distance. If we've gotten close enough, we're going to be successful. All right, that's it. Let's try to make this into a tree now. Okay, so we don't have visual scripting to make this work, so we're going to have to try to make it work for in scripting. So, all right, this is a very simple AI controller right now. We're going to add a few things to make it work. A lot of our logic just exists inside the behavior tree. So let's think about this. We need to, the first thing we're going to need, and you'll see how I set this up. So the first thing we need is going to be something called we're going to need to define them all up here. So let's just define our behavior is up here. Okay, so the first thing we're going to have is a selector called a root. So public selector and root AI. Okay, so we're using our class from our behavior tree. We're creating one in here called root AI. All right, and it's going to be a selector. So in our start menu, you can say root AI, and we can use our constructor to construct this. Equals new selector, and then we can make a list, new list of BT node, and then we can set up our list. Okay, so our selector needs to check to see if we are let's see here. We need to check to see if we have arrived at our target, and if we have, then we need to select a new target, and then if we have not arrived at our target, we need to move. Okay, so that's going to require two different sequences. Okay, so let's just for clarity's sake, we'll just name them right now. So check. I'm going to call this check arrival sequence, and then the next one I'm going to call move sequence. Okay, so you can call this whatever you want. And up here, we'll make a sequence called check arrival sequence, and we'll make another one called move sequence. Okay. All right. So once we have our check arrival sequence and our move sequence defined up here, we can now fill these up. So our root AI has them, but that doesn't really mean anything, right? So we have to define these and fill them up before we get to the root AI in the start menu. So we're going to define these up here. So we're going to say check arrival sequence equals new sequence BG node. Oh wait, check arrival sequence equals new sequence list.bg node. Okay, now we need to fill this up with the list. Okay, and there we go. Okay, so to check the arrival, we need to check the arrival task. Okay, so you just do new check arrival task. Okay, and what does it take? It takes the AI. So you can just type this. So this is going to just reference the class that we're in right now, which is the AI controller, and the AI controller derives from the iBehavior. So AI. So you can say this. So we're just going to pass this object, this class, into here, and that will be the AI. Okay, so we're going to check. Now it's a sequence. If you check the arrival task and we are successful, that means we've gotten to the destination. So we need to move on to the next thing. So the next thing we want to do is find a wonder point task, And in here, we need to pass our AI controller and a range. And so let's make the range 500F. Okay, so now our AI is going to search, or is going to do like a wander point within 500 meters of the center of the map. Okay, so good. All right, so now let's just be lazy. We'll copy this over. I know this is a long video. We want to do move sequence. Okay, so move sequence is a new sequence. And we're going to have two new things in the move sequence. So what do we have to do to move? We need to turn to our target and then thrust forward, right? So turn to target task, this, and then we need to pass in our turn event. So our turn event is just called turn event. All right. And now we need to move to target task, this, and then we need a range. So let's say our range is 100, and we need our forward event. Okay, so now we have our two sequences. Okay, so this is basically our behavior tree. Each one of these fits in. So in the root, you're going to select, first you're going to go to check arrival. It's going to say, did we reach our destination? Yes. Let's go to find a new wander point, reset. If no, then we haven't gotten to our point yet. We're going to turn to the target, and then we're going to move to the target. That's in our move sequence. Okay, so that is the beginning of that. The one last thing I've found was helpful was just in the start script, just call the find wander point task once before we run anything. We'll just give it a 500, and that way you'll set a wander task. I think, I don't know, it might just go to 0, right? So this will make it a little bit more interesting. Okay, so if we do that, now in our update script, we are going to call the root AI dot evaluate. Now what that's going to do is it's going to set off the chain. It's going to, every update, it's going to evaluate our behavior tree. It's going to start in a selector. It's going to do these things. It's going to go through. It's going to come back, do it again. Okay, so that is how you run your behavior tree, just root evaluate in the update statement. And that might be everything we need. Let's see what happens. Okay, so how do we set this up? All right, so one easy way to do it is grab the ship, the player ship that you have, and just duplicate it. And we'll stick them over here, just move them away from the player a little bit. All right, and then we can rename it to enemy ship. Okay, so now we have our, we don't need the particle system for the enemy. We don't need a camera for the enemy. Okay, probably don't even need guns for the enemy right now. Let's just leave them on. Okay, so on the enemy ship you have a ship controller, a rigid body, and a box collider. So a couple of things we need to do here. We need to find the AI controller that we created, drag it on to the enemy ship. Okay, so now we have the AI controller on here. The AI controller is going to be the pilot. So in order to get this to be the pilot, just drag your this should work. Okay, why isn't it working? Oh, my okay, so my UI is not working. That's not cool. Okay, how am I gonna do this without it working? Okay, so here, I'm gonna save my project and just close it down if I can, and just quickly reboot it. Let's see, can I close it? Okay, so we'll just quickly fire it up again. and hopefully we'll have everything the way we want it. Okay, so basically while we're waiting for this to fire up, here we go. We have our enemy ship. Man, what is wrong with this thing? I wonder if anyone else has had this kind of bug. I can... Huh. It's like my inspector is broken. Interesting. Okay. Can I add an inspector now and do it? Okay, so I'm going to just remove this component and add the ship controller again. Man, this is not cool. Okay, Okay, so let's go into the ship controller here, and we will on awake, we will say, how can we do this? Okay, so if player input I think if we do this, if there is no player input, oh, we have to do if there's no pilot. Okay, and then get component. Pilot equals game object. Alright, so let's see if that works. Man, okay. So hopefully we can do this without Unity being too janky. Okay, right now our ship component is empty. Our yaw speeds and stuff are going to be really slow, but maybe it doesn't matter. Okay, so we have this. We have our AI controller. It's going to grab this and make that the pilot. And then, yeah, let's see what happens. I don't know. Okay, so yeah. So you'll see the AI has figured out that it has a pilot. It's currently flying away here. It's just picking random points. It's probably going to crash into something because it has no collision detection. But it also has a very slow turn speed, so... Oh, just picked a new one. It got close. Now it's going to crash into that. So there you have it. I think this is a good place to kind of wrap up for this video. And we'll pick up later to add some more features like chasing the player and allowing the enemy to shoot lasers at you, and then it can actually kind of turn into a game. So I hope you found this instructive and interesting. And please like and subscribe, and I'll see you on the next video.